talking about these. Oh, these. So the thing is, I've got to mount the brake caliper relative to the rotor. The caliper has to be untangled. The set of calipers, has to sit on the rotor like that, so that the rotor can spin, and then this can clamp down and stop it. That's the whole point of brakes. Figuring out what the relative mounting positions for the bolt holes, for the screw holes, for that relative to the axle in both a radial measurement and an axial measurement is difficult. The numbers must exist somewhere, there must be technical drawings somewhere, but there are many different mounting systems, and I contacted manufacturers even, and I could not get technical drawings which showed those relative positions. So I had to figure them out. And so I used 3D printing to figure out these dimensions. And so we started with revision A. So this is the dropout, which is now welded to the frame. This is the same model as the dropout is in steel, and this is the bottom edge. This is the bottom edge of the 50 by 25 rail that is welded to. This is just a block which in this model simply serves to position these two flats. And so then we can take this and sit it on the axle and tighten it up, and now that is how it will function on the trailer. And so these flats are now located relative to the flange at the back here in terms of the axial position, and relative to the axle in terms of their radial positions. And so then we can take the caliper and test fit it on there and realize, oh yeah, okay, the axial number is significantly off, and the radial numbers are off, and blah, blah, blah. And so we iterate and iterate and iterate. We go through revision A, and then revision B, which starts to remove a lot of material. It's just like, well, we don't need to keep them parallel. We can rotate the whole thing, so we can lose some material. Revision B, same thing, fit it on, find out what happens, and tweak the positions. By revision B, I think I had the axial position sorted out, but the radial position I was still tweaking. So as we go through revision B to revision C, we start to tune that, to really fine tune the radial position, so the position of these two flats in that axis. And at the same time start to fine tune some features for machinability, because this piece is going to be machined out of steel and then welded onto the frame as well. So start to fine tune for machinability. We go through revision D, which again start to remove more material to make it more machinable. Revision E, at the same time as finding out what these positions are, essentially just referenced back to the axle position in here. What I'm also doing is figuring out how we're going to accurately locate this piece once it's machined out of steel to weld it to that piece, to the flat there on the 50 by 25 rail. Remember, this whole thing's that way up. And so originally, trying to get to revision F, and in revision F, these positions are correct, and the idea of the shape here is that I can clamp it very firmly to the rail, and at the back of the rail here it has a lip. In fact, I then printed the final version, the freestanding piece, and so this flat here will sit against the dropout like that, and then this flat here will sit against the rail and it can be clamped down hard, and this lip, this little flange here, will sit hard up against the back of that rail, sort of like that, to locate it in that axis. Problem was, in reality on the trailer, the dropout is not perfectly aligned with that rail. The dropouts are parallel and they're 100 millimeters apart to within about 0.2 of a millimeter, which is what they need to be to hold the axle of the wheel well. But the rails are much more sort of crudely positioned than that, and so that means that the alignment between the dropout and the rail is not perfect. That meant that referencing this to the back edge of that rail is a problem. In reality, it turns out that this dropout is slightly that way. So there's a little bit of an extra lip of rail here, and that positioned this incorrectly relative to the axle, relative to the wheel. So, redesign, finally, revision G. Revision G has the hole here, which mates with the hole on the dropout. This flat interfaces with the dropout there, and then the flat on the bottom interfaces with the rail. And so this is referenced entirely to the dropout now and the surface where the dropout meets the rail. This being referenced to that means that the brake caliper is in the right position. So this is the final piece, and I clamped it in place on the trailer, and it worked. The positioning was correct. So I've got the brake caliper mounted on revision G. I think of the 3D printed adapter, which is just to test the dimensions. And then this 3D part will be machined out of tool steel, and once it's been made out of tool steel, it will weld it in place. We'll fasten it with a bolt here to position it, and it's referenced to this piece, and therefore pretty well referenced to the axle. The tolerances between the hub motor and the calipers are extremely tight. See that down there. And apologies for the wind. But there's your tiny tolerance. And it feels pretty solid. Remarkably effective just with that 3D printed part. Let's see if I can do this. I don't have enough hands. You can see here the tolerances are really tight between the caliper there and the hub motor. This is with the spacer, so this is brought out, and now we can line up the caliper on the brake disc properly, and that will mean that if I had a third hand I could spin this wheel. Yeah, tolerances are real tight, as you can see, both between the caliper and the if I can move the camera right in there. The caliper and the motor, there's like a millimeter. Actually, technically, it should be about 1.5. And then between the rotor screw heads and the inside of the frame here, particularly the brake mount weld there. So that well, obviously not having the caliper screwed on doesn't help. Here we go. Look. There you go, everything spins.